Hello dear students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to continue the amines chapter, and in today's lecture we are going to discuss about the physical properties and the chemical reactions of amines. Okay, so please join our WhatsApp channel because you will be getting access to the PDF of this, class notes, and you can get access to our mock test question paper, solutions, everything through the WhatsApp channel. So please do not forget to join the WhatsApp channel. Okay, so now I want all of you to sit with a notebook and pen, as I say in my every class, so that you can note down all the reactions. You can know how to make flow chart of these reactions and keep them for revision as well. So yes, now without any further delay, let's get started. I hope all of you are ready for today's class. Okay, so coming to the how are we going to complete this chapter? So this I have already told you. We'll be doing it in three parts. So generally for all the organic chemistry I took 4 parts. Here I'll be, because it is a small chapter, we can manage it within 3 parts. So in the last class we have already discussed about the structure of ammonia. Then we have discussed about the classification, primary, secondary and tertiary amines. Then we have discussed about the nomenclature, and then we discussed about the preparation of amines, right? Now coming to the part 2, that is today's lecture, we are going to cover physical properties and chemical reactions of amines, and in the next class we will be doing diazonium salts, where we will be talking about its preparation, physical properties and chemical reactions. Okay, so now focus on today's class, that is physical properties and chemical reactions. So now if we come year wise weightage, so you can see 2-3 questions are asked every year, so you can expect easily 2 to 3 questions from this particular chapter. Okay, now coming to the topic of today, that I already told you, physical properties and chemical reactions. So under chemical reactions we are having today 6 reactions. Okay, so the first one is the basic nature. So here, as I told you, this is not a reaction, but from here questions have been asked repeatedly. Okay, so this is an important topic. Next you have alkylation, next we have acylation, next carbyl-amine reaction, next we have reactions with nitric acid, then we have reaction with aryl sulfonyl chloride, and then we have electrophilic substitution reaction. So I told you 6 reactions, by mistake it is 7 reactions. Okay, what are these 7 reactions? Let us revise once again. Basic nature we will first discuss, then we have alkylation, then we have acylation, then we have carbyl-amine reaction, then you have reactions with nitric acid, reaction with aryl sulfonyl chloride. This reaction is also very important. This is also very important. Carbyl-amine reactions very important. Then we'll talk about electrophilic substitution reactions. Okay, so now coming to the first thing, that is your under electrophilic substitution we have 3 reactions: nitration, sulfonation and halogenation. We'll be talking about them also today. Now coming to the first topic, that is physical properties. Generally in physical properties we talk about solubility and boiling point, right? So coming about the solubility, so the amines are able to form hydrogen bond also. So like as you have studied in all other cases, lower aliphatic amines are soluble in water because they can form hydrogen bonds with the water molecules. However, solubility decreases with the increase in the molar mass of the amines due to the increase in the size of the hydrophobic alkyl part. So this is RNH2, right? Now if this R group is a smaller one, okay, less Henrich, smaller group, then it will be easily soluble in water. If this R group keeps on increasing, the solubility keeps on decreasing. Okay, first thing. Next, coming to boiling point. So if you see here what happens, primary amines, okay, we have 2H, right? Secondary amines, you have 1H, and then we have tertiary amines where you have no H. Now because of 2H here, there is more extensive hydrogen bonding here, extensive hydrogen bonding, right? Here only 1H is there, so here it is, here less hydrogen bonding, and here it is very less hydrogen bonding. Due to this nitrogen we have some hydrogen bonding here. So more is the hydrogen bonding, more will be the intermolecular force of attraction, and higher will be the boiling point. So because here more number of H is there is more stronger hydrogen bonding, that is why its boiling point is highest. So the order is like this: primary, secondary and tertiary. I hope this is clear. This is because of what? This is because of hydrogen bonding. Okay, fine. Now coming to the next one, that is your chemical reactions. In chemical reactions, we will be discussing, as I told you, total 7 reactions or 7 properties we are going to study. So the first one is your basic nature. We will talk about basic nature. This is very important topic, basic nature. Okay, next we have alkylation, next we have acylation, fourth we have carbylamine reaction. Again, this is very important, carbylamine reaction. Then you have reaction with nitric acid, reaction with aryl sulfonic acid. These all the 7 reactions are very important. Then we have electrophilic substitution reaction. Now coming to under electrophilic substitution reaction, we have nitration, sulfonation and halogenation. Okay, so let us now recall all the 7 reactions once again. First is basic nature, second we have alkylation, third we have acylation, fourth we have carbylamine reaction, fifth you have reactions with nitric acid, sixth benzene sulfonyl chloride reaction, and seventh one is your electrophilic substitution reaction. Once again let us revise. First one we will talk about the basic nature, second one we are going to discuss about the alkylation, third acylation, then fourth one is your carbylamine reaction, fifth one reaction with nitric acid, sixth one benzene sulfonyl chloride, and seventh one electrophilic substitution reaction. Okay, so first one is basic nature, very important. Let us now discuss the basic nature. Okay, so here questions are asked repeatedly, so you have to understand that basic nature means what? Tendency to donate electrons, right? So nitrogen has lone pair of electrons, so nitrogen has lone pair of electrons. Now the tendency of this lone pair of electrons to be donated is called as your basic nature of amines. Now if you have tertiary group, okay, so you have tertiary group here, then you have secondary group, and then you have primary group, right? Now what happens, if you see this R group are having plus I effect, so they will donate electrons, so the electron density on the nitrogen increases, as a result of which donation becomes easier here, right? So in the gaseous phase the order is 3 degree, 2 degree, 1 degree, okay, 3 degree, 2 degree and 1 degree. Okay, this you have to remember, very important, this is in the gaseous phase. Now what happens in the when you take it in the aqueous phase? Now what happens when aqueous phase is there, okay, so you have N, you have R, okay, and then you have N, you have R, you have H, you have H, sorry, secondary, and then you have primary. Okay, so now what happens, these hydrogens are involved in hydrogen bonding, right? These all are involved with hydrogen bonding. Here there is hydrogen bonding, right? So now due to this hydrogen bonding, what happens, this primary group, okay, because of 2 hydrogen groups it has more number of hydrogen bonding, the primary group is more stable, secondary, tertiary. This is the order, okay. But the inductive effect wise, like of the inductive effect wise, if you see, the opposite happens. So now there is a mixture of these 2 effects, and the result that we get is, for if your R group is ethyl group, okay, then we have the order 2 degree, 3 degree, 1 degree, okay. For ethyl group you have 2 degree, 3 degree and then 1 degree. And if your R group is methyl group, then the order is 2 degree, 1 degree and then 3 degree. Okay, this is 2 degree, 1 degree, 3 degree and then ammonia. Clear? Once again I will tell you, if the solution, if the amines are taken in the aqueous phase, then there are 2 factors that is determining. One is your inductive effect and another is your solvation effect. So because of the mixture of these 2 effects, we find the order like this. For ethyl amines, okay, for if the R group is ethyl group, then the order is 2 degree, 3 degree, 1 degree, and if the R group is methyl group, then it is 2 degree, 1 degree, 3 degree. Okay, 2, 3, 1 for ethyl, 2, 1, 3 for methyl. Okay, next coming to aryl amines versus ammonia. Now if you see here, let me erase this one. So one second. Okay, so here I wrote you it is 3 degree. Okay. Yeah, so here it is 3 degree, 2 degree, 1 degree in the gaseous phase. If R is equal to ethyl group, C2H5 group, then we have 2 degree, 3 degree and 1 degree. And if your R is equal to methyl group, then it is 2 degree, then you have 1 degree and then 3 degree. Now coming to aryl amines versus ammonia. So now if you see NH2 group, okay, this is aryl amines, or we can call it aniline, right? So now what happens, due to this lone pair of electrons, what happens, it undergoes it undergoes resonance with the benzene ring. Now if it undergoes resonance with the benzene ring, this lone pair is not available for donation, not available for donation, and as a result of what, basicity decreases, right? So that is what is told here. Aryl amines are less basic than ammonia, because why? The lone pair of nitrogen in the aryl amines is involved in resonance. Okay, fine. So now let us go to the next one. Here some questions will solve about the basicity order now. The strongest base among the following. So here you can see this is aryl group, this is aryl group. This one here C2H5 whole 2 NH is there, and here NH3 is there. So this is 2 degree. So definitely 2 degree is more than your ammonia, and these are also more than your arylic amines. So correct answer is option number D. Okay, next, the decreasing order of basic character of 3 amines and ammonia. See, now when there is not mentioned whether it is gaseous phase or aqueous phase, you have to assume as gaseous phase. Okay, so gaseous phase the order is 3 degree, 2 degree, 1 degree, right? So you can see here, okay, so question here is about different thing. We have one aryl amine. So aryl amine should be least one, right? Ammonia, less than ammonia, even aryl amines come. So we can eliminate these two options. Here aryl amines are least, and before aryl amines there should be ammonia. Here ammonia is there. Now here you have like C2H5 group, and here you have CH3NH2 group. So correct answer is option number B. Okay, because if R groups are there, they will donate the electrons, right? And that will help to increase the basicity, or that will help to increase the electron density on the nitrogen, as a result of which the basicity will increase. Okay, next one. Which of the following is the strongest base? So we need something here which can give electrons to this one, right? Now if you see here, these electrons are involved in resonance, these electrons are involved in resonance, this electron is also involved in resonance, but these electrons are not involved in resonance, right? So this can be donated very easily. So correct answer is option number D here. Very simple. Next one. Arrange the following amines in the order of increasing basicity. Okay, so now if you see here, first of all we have N-butyl amine. So I have CH3, CH2, CH2, and then another CH2, NH2. Okay, next you have secondary butyl amine. So that means you have CH3, CH, NH2, CH2, CH3. Okay, so this is your first compound and this is second compound. Next, third one is isobutyl amine. So if you see isobutyl group is like this, CH3, this is isobutyl, CH2, NH2. Okay, next you have tert butyl amine. So this is your third one. Okay, now tert butyl amine, if I draw like this is NH2. Okay, now if you see this all are your primary amines, right? So donation will be easier if there is less steric hindrance. So what happens here, there is primary amines, this will donate better because there is no steric hindrance. So one has to be, you have to arrange it in the increasing order of basicity, right? So one has to be highest. After one you can see it has to be 2, then you have 3, and then you have 4. So correct answer is option number C. Okay. Okay. Now let us see the next question. The weakest base among the following. So you can see these all are your aliphatic amines. This is a aromatic amine. So aromatic amine, the lone pair of nitrogen is involved in resonance. So that is a weak base. So correct answer is option number B here. Okay. Next, arrange the following in the decreasing order of their basic strength. So decreasing order of their basic strength. So if you see, first of all, let us draw the structure. You have C6H5NH2, then you have C2H5NH2. Okay, next you have C2H5 whole 2 NH, so CH3 CH2 NH CH2 CH3, then you have NH3. Okay, now if you see here, first of all, the secondary amines are more aromatic, so this one will come first. So you have C2H5 whole 2 NH. Okay, then primary amine, because here donation will be there only from one side, CH3 CH2 NH2. Okay, next if you see, you will have ammonia. Okay, and at the last you have aniline. Okay, so because aniline, lone pair of electrons on nitrogen will be involved in resonance, so correct answer will be, this will be the order. Okay, fine. Now talking about the chemical reactions, one second. Okay, so now coming to the chemical reactions of amine. So we have told you there were 7 chemical reactions, right? First one was the basic nature that we have discussed. Now the second chemical reaction was your alkylation. So this is your second one, that is alkylation. So now alkylation, we have already studied the reactions of alkylation in the previous chapter, where we have discussed about the preparation of ammonia, right? Previous, not chapter, previous lecture. So what happens, as you know, this is delta minus, this is delta plus. So this bond will attack here, this X will go. So what I'll get? We'll get a secondary amine. Now again further this reaction will continue and we can get tertiary and quaternary amines as well. Okay. Now the second reaction is alkylation. I hope this is clear. Next one, the third one is your, I'll write here, acylation. Okay. So for acylation, you can react it with either acid chloride, you can either react with acid chlorides, okay, or you can react with anhydrides. Either acid chlorides or anhydrides. Now what you see here, what you have to do, just you have to replace one hydrogen with COR group. Okay, so if you see what I have done, RNH, and this one H is replaced with COR group. Okay, that is nothing but your acylation. Similarly, you can also do with anhydrides. Again, replace this H with RCO group. So you can see RNHCOR has come here, right? Now there is another one more is there. You can react with benzyl chloride also. Benzoyl chloride. Okay, so this is benzoyl chloride. Benzoyl chloride, right? So what will happen? One of the H will be replaced with COC6H5, this group, acyl group, right? COC6H5. Now this is not called as acylation because you are adding a benzoyl group. This is called as benzoylation. Okay, clear? So this all comes under acylation. You can treat it with acid chlorides or you can treat it with anhydrides, and we have one special reaction, that is your benzoylation. Now the third reaction, so 1, 2, 3. Now fourth reaction was with carbyl amine test, right? So this is your fourth reaction, that is reaction with carbyl amine. Carbyl amine. Now if you see carbyl amine, what you just take, you need to take chloroform with KOH, we get RNC. Okay, now this RNC is what? It is your isocyanide, right? Isocyanide. And this is very, very important. This isocyanide compound has a foul smell. Okay, and one more important thing, only primary amines can react here. Only primary amines can react with CHCl3 KOH to give you isocyanide. That is called as your carbyl amine test. So with this foul smell, we can easily identify the amines that was given to us is nothing but your primary amine. Okay, so remember this one. This is very important that only primary amines give this test. Okay, only primary amines will react with carbyl amine reagent, that is CHCl3KOH, to give you isocyanide which has a foul smell. Okay, so next, so we have done with 4 reactions. The 5th reaction is with your nitric acid. 5th reaction is with nitric acid. Okay, sorry, not nitric acid, this is nitrous acid. Okay, yeah, so we have nitrous acid. Now here you have to remember that if this R group, okay, if it is an aliphatic amine, then we get alcohols, right? We get alcohols if it is aliphatic amine. But if it is aniline, that is this R group is aromatic, then we get benzene diazonium chloride. Benzene diazonium chloride. Okay, for this what should be condition? The R should be an aromatic ring. Clear? Let us revise once again. First we talked about the basic nature and we practiced some questions. Second reaction is alkylation. Here the reaction is done with Rx and we get mixture of primary, secondary, tertiary amines. The third reaction is acylation. Here we react either with acyl chlorides or we can react with anhydrides. Simply have to replace one H of amine with CO, like a CH3CO group. Okay. Next we have 4th reaction, that is your reaction carbyl amine test. So this is given only by primary amines. Reagent used is CHCl3KOH. Okay. Once you do this, you get isocyanates and it has a foul smell from which it can be easily identified. Now the 5th one is your nitrous acid. So if R group, if it is an aliphatic amine, with nitrous acid we will get alcohols. If it is an aromatic amine, that is aniline, then with nitrous acid we will get benzene diazonium chloride. Clear? Now we will go to the 6th reaction, that is benzene that is your reaction with benzene sulfonic chloride. Okay. Now this is also, you should remember that this reagent is also called as Hinsberg reagent. Hinsberg reagent. Okay, and what is it is used? It is used to test primary, secondary and tertiary amines. Used to test primary, secondary and tertiary amines. Now how we will discuss. Now see, first of all what happens, suppose if it is a primary amine, okay, so this is what? Primary amine. This is benzene sulfonyl chloride, from here HCl goes, okay, and we get a compound S double bond O NHR, right? Now what happens, due to this presence of this H which is highly acidic, okay, it reacts with alkali and you can say it is soluble in alkali. Soluble in alkali. Okay, so now once this product is formed, if you just add NaOH, suppose if you add NaOH, any alkali, it will be soluble in that alkali. Now coming to the secondary amines. If you see for secondary amines, what will happen? Again this H and Cl will go, right? This part will go and we are left with S double bond O NRR, right? Now here you see there is no acidic H, it has no acidic H. So that implies what? This will be insoluble in alkali. This will be insoluble in alkali. Clear? Now if you see tertiary, so there is no H to react with Cl. So that is why here there is no reaction at all. Clear? So how can we differentiate using the benzene diazonium, how can we differentiate using benzene sulfonic chloride, or we call it Hinsberg reagent? Primary amines will react and if you add alkali, it will be soluble. Secondary amines will react, but if you add alkali, it will be insoluble, and tertiary will not react at all. Okay, fine. Next we'll go to the 7th reaction, that is your electrophilic substitution reaction. Okay, 7th one is electrophilic substitution reaction. Under this, first one is your halogenation. Okay, I told you 3 reactions are there: halogenation, sulfonation and nitration. So if you add, the first one here is halogenation. So now if you just add bromine and water, this NH2 group, if you remember, it is electron donating group. That means it is ortho-para directing group. Okay. So now what happens, this is highly activating ring, it activates the ring, and the bromine gets replaced at ortho and para position at the same time. Like if you remember phenol reaction, similar to that, this reaction happens and all the three positions of bromine, all the three positions ortho and para are occupied by bromine. Okay. Now coming to, if you do nitration, okay, concentrated HNO3 and H2SO4 if you do, okay. So here what happens, we get a mixture of products. So you might be thinking that we will be getting ortho and para product, right? Now what happens, we get para product 51%, but the meta product is formed 47%. Meta product is formed 47%. Now what is the reason for that? Please understand carefully. This is acidic medium, right? So this lone pair of nitrogen takes this H and becomes NH3 plus. What does it converts to? It becomes like this. Okay. Now what happens, this becomes a electron withdrawing group, and if it is an electron withdrawing group, it will be directing to the meta position. So that is why we can find almost 47% of the product is found in the meta position. And then you have ortho product, 2% of ortho product, because it is ortho para directing. Clear? So this is your second one, that is nitration. Okay. Next, coming to the reaction here with sulfonation. Okay. So this is your third reaction, that is sulfonation. Let me write it. Okay, one second. Yeah. So next one is your sulfonation. So I'll write here third one, sulfonation. Okay. Now in sulfonation what happens, just first you treat this one, as you saw here, it will give you H plus. So we will get NH3 plus and HSO4 minus. Okay. After that what happens, there is a shifting here, and this SO3H goes to the para position. Okay. Once it goes to the para position, then there is a proton transfer. Okay, proton transfer. So what happens, this H comes here, we get NH3 plus and SO3 minus. Okay. Sulfonation reaction not very important, just you need to understand, first the salt is formed, then this HSO3 group comes down, and then there is a proton transfer and we get this one. Okay. Okay. Now coming to one important thing, as you saw here that bromination and nitration is giving you a mixture of products, right? So there is a way by which you can, okay, so I just write it here, this is electron donating group. Yeah. So this is electron donating group, so it is ortho para directing, right? And this reaction is your halogenation, or you can say bromination. Halogenation reaction, first one, and the second one is your nitration reaction, right? And third one is sulfonation reaction. So now what happens, if we want to reduce the reactivity of this amine group, okay, you can reduce its reactivity by treating it with anhydrides. Okay. So now we'll get this NHCOCH3. Now how does it reduces the reactivity? Now see, earlier this lone pair of electrons were involved in resonance with the benzene ring, and it was increasing the electron density of the benzene ring. But now if you see, this also has CO is like this. So this nitrogen electron pair can also go resonance here and can also go here. So it is now divided, right? So that is why the reactivity or the nature of activating the benzene ring by this amine group has reduced now, because the lone pair of electrons is involved in resonance in two sides now. Earlier it was 100% on this side, right? 100% it was undergoing resonance here. So the ring electron density was increasing. But now the electron sometimes moving there, sometimes moving here. So that is why the activation of the benzene ring has now decreased. Now if you do halogenation, bromine if you add, we will get only para product, the major product you will get para product. Now to remove this NHCOCH3, just treat it with OH minus or H plus, you will get NH2 back. Okay. Similarly from here, if you treat it with concentrated HNO3 or H2SO4, you will get only para product. Again treat it with OH minus and H plus, you will get NH2 group back. Okay, so first of all, if you do direct nitration, you will get 3 ortho para meta product. If you do direct bromination, then you will get all the 3 positions are occupied. But if you reduce the reactivity, how to reduce the reactivity? By treating it with any anhydride. So we will get NHCOCH3 like compound. Now if you do bromination, you will get only para product, and then you can reduce this NHCOCH3 to NH2 by treating with H plus or OH minus. Okay, fine. So now coming to the, so we have already discussed all the reactions. Now let us do first one revision, then we'll go to the questions. Okay, yeah. So basic nature, what is there? The important things under basic nature. So let me clear the screen, then we'll write out the new things that we have revised. So what we have studied under basic nature? 3 points. First important thing is in the gaseous phase, what is the order? 3 degree, 2 degree and then 1 degree. In the aqueous phase, right, we have 2 orders here. If it is methyl group, then the order is 2, 1, 3, right, and if it is ethyl group, then the order is 2, 3, 1. Okay. One more important point that we have studied is your aniline. Aniline is less basic than ammonia. Okay. Now coming to alkylation, you have to just treat with RX. Acylation, you can treat it with RCOCl or with anhydride. Okay. Next, with carbyl amine test, what is the reagent? CHCl3 in presence of KOH. Right, and this is given by only primary amines, right, used as a test. Okay, and what is formed here? Isocyanide is formed, which has a foul smell. Right. Next, with nitric acid, it will give you, if it is aliphatic, then we will get alcohols. If it is aromatic, we'll get benzene diazonium chloride. Now with aryl sulfonyl chloride, we have 3 things here. Primary one will react and will be soluble, secondary will react but insoluble, and tertiary will not react. Okay. In nitration, sulfonation and halogenation, we have just discussed. In nitration, if you do direct nitration, we will get ortho para meta positions. If you first reduce the reactivity, then we will get only para product. Similarly, halogenation, if you do directly, all the ortho para positions will be substituted very easily, and to reduce the reactivity you can treat it with anhydride, and then if you do halogenation will get only para product. Okay, so I hope this is done, this is all clear. Now we'll go to practice some questions. So this was the homework question that I gave you. Which one of the following compounds gives a secondary amine? So secondary amine, if you remember, isocyanide will give you secondary amine, so correct answer is option number C. Okay, now coming to the 7th question here. Ethyl amine reacts with nitrous acid to give ethyl amine CH3 CH2 NH2. So this is an aliphatic amine, right? Just now we discussed reaction with nitrous acid. So aliphatic amine will give you what? Alcohol, right? So we will get ethanol, that is ethyl alcohol. So correct answer is option number C. Next, when ethyl amine is heated with chloroform and alcoholic KOH, a bad order compound is formed. The compound is, so just now we discussed it is an isocyanate compound, and only primary amines will give you this test. Okay, so correct answer is option number D. Next, the compound which does not react with CH3COCl. So if you see what is the reaction, just now we discussed the reaction with first acylation, right? So what happens, suppose here you have NH2 N R R. So this HCl goes and we get amides as a product, right? One thing I forgot to tell you that yeah, these products are called as your amides. Okay. 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 So now if you see, we have this one. So here there is no H, right? In R3N there is no H, so there is no formation of amides here. Correct answer is option number C. Next, which of the following compounds will form alcohol on treatment with NaNO2 HCl and water? So if you remember, NaNO2 HCl is nothing but your nitrous acid, right? So for formation of alcohol, we need we need aliphatic amines, right? We need aliphatic amines. So now if you see, this is aromatic, this is aromatic, this is aromatic, this is aliphatic. So correct answer is option number A. Okay. Next question, identify A, B and C in the sequence of reaction. So first of all, if you treat it with KCN, what I'll get? CH3, CH2, CN, right? So this is CN, this is CN, this is NC, so we can eliminate this option. So this is your A, right? After that, LiAlH4, that is reduction of this one, so we will get CH3, CH2, right? Then we have CH2, NH2, right? So we'll get a primary amine here. So if you see here, we have got alcohol, so we can eliminate this option. Here CH3, CH2, NH2, here also we have CH3, CH2, NH2. I think 1, 2, 3, and here you have only 2 carbons, right? So there will be no decrease in the carbon number, so this is also wrong. Correct answer is option number A. Now if you treat it with HNO2, just now we discussed primary amines on treating with nitrous acid will give you alcohols, right? So we'll get CH3, CH2, 3H2OH. So that is this one. So correct answer is option number A here. Okay, next question. Again you have to identify, okay, this is same question repeated. Okay, the correct answer is option number A again. Next one, aniline does not undergo. Okay, so this is very important question, that aniline does not undergo Friedel-Crafts reaction. Now what is the reason for that? Understand, you have aniline like this. Okay, now this has a acidic basic nature, right? It is a base. Now when for Friedel-Crafts alkylation or acylation, what is the reagent? CH3Cl, AlCl3, right? And this AlCl3 is nothing but a Lewis acid, right? So now what happens here, there is a reaction between this base and this acid. Okay, so we get a compound like this, right? NaCl3. So this is a salt formed here, right? So because of this salt formation, there cannot be, like I can say, no electrophile is generated. Generally what happens, these two will react to give you CH3 plus, which is the electrophile, right? But in case of aniline, there is no generation of electrophile, so that is why it cannot undergo Friedel-Crafts reaction. Okay, next, in carbylamine test for primary amines, the resulting foul smell compound is, so isocyanide, that is CH3NC. So correct answer is option number A. Okay, next question, you have to find the product. First, NO2, Br2, FeBr3. So if you remember, NO2 is what? It is an electron withdrawing group. So where position of Br will be? At the meta position. So I'll get like this. We have NO2 and then we have Br. This is option, like this is P. After that you are doing SN and concentrated HCl. So this is reduction of nitro compounds. So this one will give you NH2 with Br. Okay. Now you are treating with NaNO2 HCl dilute. So this is what I told you, nitrous acid. So if you have aromatic amines and nitric acid is there, that will give you benzene disonium chloride. So we will get N2 plus Cl minus and bromine. Next, if you warm it with water, what happens? This gets replaced with OH. Okay. This gets replaced with OH. So you can see this is the correct answer. So option number A is the correct answer here. So here this compound is never formed. Here NH2 will be converted to benzene disonium chloride. So that is why correct answer is option number A. Okay, next question. Hinsberg reagent is, so I told you Hinsberg reagent is C6H5SO2Cl. Okay, correct answer is option number A. Next, if aniline is treated with 1:1 mixture of concentrated HNO3 and concentrated H2SO4, para-nitroaniline and meta-nitroaniline are formed in nearly equal amounts. So you remember, para forms in 51% and meta forms is 47%, right? This is due to, so just now we have discussed that nitro NH2 group takes the H plus and becomes NH3 plus, and now it is an electron withdrawing group, and now it is meta directing group. So what happens here? What is the reason for that? Meta directing property of NH2 group, protonation of NH2 which causes ortho deactivation of benzene ring, meta and para directing property of NH2 group, isomerization of some para nitro to meta. So this is not there. NH2 group does not have meta and para directing nature. This one can be the correct answer. The protonation of NH2 group causes deactivation of the benzene ring. Okay, causes deactivation of benzene ring. So correct answer is option number B here. Okay. So here's a homework question for you now. An aromatic compound AC7H9N on reacting with NaNO2HCl at 0 degrees Celsius forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A. So just try this question. I'll be explaining you it in the next class. Okay. Okay students, so we are done with today's lecture. So amines, chemical reactions and everything we have studied. I hope that you have prepared a flow chart and paste it, and then you have to revise it every day. So I hope you have enjoyed the class. If you have any doubt in any question, do comment down. I'll definitely answer, and also do not forget to comment down the answer of the homework question. Okay, so thank you for watching, and please subscribe the channel, and please do not forget to subscribe the channel, and all the very best for your KCET 2025 preparation. Remember your target 60 out of 60 in KCET Chemistry. Thank you for watching once again, and see you soon in the next class.